Okay, John, do you want to tell us what we've got here and how this relates to what we just filmed about what was going on in the oven and so forth?
Oh yeah, this is relates to the Sajeka files, and
and who was Sajeka?
John Sajeka was a scientist of a type, but probably more or less worked for the Black Ops, and he would go around to each company and collect different bits and pieces of information, and just collect the materials on it, and then after that the company would be out of business after that. And so what this actually relates to is when we were building these crystals, we were shown a process, and of course you had to have a very open mind, because the normal electronics engineer would not, he would just say bull to this. It just didn't exist. You couldn't make a transistor this way. You couldn't make a semiconductor material this way. You couldn't make a room temperature semiconductor this way. In reality, you could, because we have a whole board full of them here. And I'll just show it. I'll hold it up, and I'll point with my pen. This is actually a semiconductor right here. You see the two wires coming out of it, and you see the substrate, which is this big piece of brass here. Now, depending on what we were looking for and what we wanted to do, we would use a material like, if we were going for something like a silicon transistor, we'd want an aluminum base with this material. But we were going for a room temperature crystal to transfer power down number 30 wires. So what we wanted the crystal to do was add the extra energy to the wire to make up the difference. And there would be this crystal at one end transmitting the signal, and then this crystal at the other end receiving the signal. So the process was unknown at that time only to certain people, because the year is 1984, 85, right in there. And so what the process involves is a rock, just any garden variety rock that you can just go pick up off the street. Sort of like John Hutchinson's shake and bake method, only this is way before John Hutchinson. So we'd get a rock, and we would take that rock and we would mix hydrochloric acid, a 1/10 mix. In other words, 9 parts water, 1 part hydrochloric acid, and we'd mix that up and let it stand in distilled water. And then what we do is we drop the rock on the bottom. I don't know if you can see the rock that's in the bottom of this. And okay, so
yeah, we can see.
Okay, so what happens then is that this works like your stomach. It's going to digest the rock. Now, physically, you see the rock is still there, but it's actually digested all the minerals and elements out of the rock. So, okay, John, how do you get it out of there? Well, you put this iron rod in there, and you set up your jar, face the rod towards the north. That's what we were always told, face it towards the north.
Right.
Yeah, polar north.
Polar north.
And what happens after it digests it all is you get a crystal. You get a seed material.
Where does the crystal form? On?
It forms on the rod, and you get and the one we're looking for is not this. We're looking for this bottom one.
Why is that?
Because that's the actual material that's in the rock. Now we have a seed material.
Well, okay.
Have a seed material. Now, we dry that seed material out. We scrape this off and we let it all dry out. And then what we end up is a seed material like this here.
What is that material?
Which is a powder that's digested from this rock.
So what you've got in the bucket there? How many batches of this process, or of
Probably
rock?
500 batches.
Wow.
All right.
So what period of time did it take you to?
But we would use like a 5-gallon bucket to get that, and a big iron rod. In other words, like 1 inch in diameter.
So how long would it have taken?
It would take weeks and weeks and weeks, maybe 3-4 weeks, maybe 2 months, depending on how quickly the rock could be dissolved. So we get the material. Now, this is one form of a seed material. And when we're dealing with this rock here, which came out of a mine in Arizona somewhere, they never would tell us where.
What do you mean? They
Well, Sajeka would never say where the mine was, but it was in Arizona somewhere.
Okay, so this is the secret sauce.
Yeah, secret sauce.
It's where the rock
Right.
came from.
So,
Yeah.
remember, this is left over from 1984 and 85, so it's been in this bag all this time, and that's the material that comes out of this rock.
Out of which rock?
Out of this rock right here,
Okay.
that came from that mine. Now, what we were doing was trying to seed the material to get a property in the material, to come out of the material. Like, for example here, when we fired this at 2,500 degrees in an oven and it all melted down on top, then what we've done here is we're showing what was in there after we had it assayed. And you can see right here the little arrow pointing, it says there's gold right there. So there's gold mixed in with this crystal. Okay, now again, an example of the seed materials in this bottle. It's kind of hard to see.
Okay.
All right.
Which particular seed material is that?
Okay, this seed material in this bottle is what's doing these crystals.
Yeah, but where did that seed? Which batch did the seed material come from?
That came from this batch right here.
Okay.
And
And this batch came from which rock?
this came from iron pyrites.
Okay.
Okay, and galenas and things like that. And
So nothing special about this.
nothing special about it because we're just digesting.
This wasn't the secret sauce.
No, there's
Yeah.
the secret sauce.
Is the rock
when we
from
say
Arizona, from Arizona?
Right. When we say secret sauce, we're saying that each one of these rocks contains a secret sauce.
Yeah.
All right, and depending on what we're looking for here, and what we want to accomplish, that's the secret sauce.
Right. Right.
Okay, and it's the method of how you digest that secret sauce, like you see right here.
That'll give you. Then that'll give you
This will give you
what you want.
whatever the material is in this rock that was laying across the railroad tracks out back, which we know is a volcanic rock. Well, many things can be in the volcanic rock. There could be, in here, there could be gold, there could be silver, there could be sulfur, high sulfur content. It could be very electrical conductive under stimulation. It could make a fantastic radio crystal. So what we're looking for is when this dries out, what we want to do is take this material and place it on a piece of oxygen-free copper. Just like you see here.
Where do you get the oxygen-free copper from?
You just buy it.
Okay.
You just buy it from a metal place. And what you do then is you fire up your kiln or your oven to 200 and 2500 degrees, and you melt it down. Now, how you have it tested is by what floats to the top when it melts, which you would term as a slag. So what it says right here is this material contains ruby, but black.
Hold on. Right.
Okay. So now when we finalize the material and we get it to the perfect purity after getting the correct process in growing the crystal, notice this is a real black ruby. You can see it's shining.
Wow. So that's a real...
That's a real black ruby.
A ruby's barrel?
Ruby. Rubies are usually red.
Yeah, no, not a barrel like
Yeah.
emerald.
Yeah, but remember, we're growing this in an oven.
Right.
And we're taking the material when it's finally melted, and we're dripping it on some and letting it cool off so we can see what it is.
Right.
Right.
And we have that assayed. So basically, this all was known. This was a known process by a man called John Sajeka, who had quite a file on seed material at the time. And if you wanted to do something, suppose you wanted to become the world's best alchemist. Well, there were companies that knew how to do this, but they weren't in the general vicinity of the public. They were hidden away. So
this process has actually been...
This process is very proprietary.
Right.
But, of course, today we're letting it out. Because why take this secret to your grave? When you can gain minerals, it works just like the body. You take in your food, and the hydrochloric acid breaks down all the material that you've consumed, and it takes the minerals, the vitamins, and all this stuff. Well, here they are. They're right here. Everything that was in that rock. So now, what we can do is take this powder and put a scoop of it on a piece of material, like you see right here. And then we can see what grows from that in the oven. And we can decide whether or not this is a good electrical conductive for, say, a room temperature semiconductor.
So what you're pointing at now is that's after being fired in the oven?
Yes, that's after being in it, and it says right here what's in it, because this has been assayed. It says ruby,
right,
gold, and silver. And that's from this material here. See, it says ruby, gold, and silver.
Okay.
Is what's coming out of this mix.
And who did the assay?
A local assayer, flame assay test.
And that was in the valley?
And it was handled by a guy that was very secretive.
Yeah.
And I can only give his first name, and that'll be Milton.
And that was in California?
Yes, it was.
Yeah.
This was done in Sylmar, California.
Yeah.
And then, now the other thing is when you find a material that works, not all these are going to produce gold or silver or copper or zinc or anything like that. Some of them are going to become an electrical conductive crystal that you want to use for something. So anyway, some of these are going to become electrically conductive, and you want to use them, say, for sound, or you want to use them, say, for power. Well, these happen to work well with power transfer. This is why they're big. They happen to filter out the noise on an AC line. So this would be in series with your AC line, and it would filter out the noise. And people in audio would use that as a line conditioner. This one over here would be used in a stereo synth.
Excuse me, backing up. Did you used to use those yourselves, or sell them to people that would use them? Or?
Yes.
Yeah.
So we made speaker conditioners. This was a speaker conditioner here. It was encapsulated, and it says right here where it was done, and the zip code and everything. And this would go in a speaker, and it would change the total sound of the speaker. It would make the speaker, say, sound more like there was a tube amp running it, but with the bottom end, the bass end, and the top end. So if you wanted to, say, do preamplifying controls, you wouldn't need a power crystal like this. See? This is more for like power. You would use something like this right here. And these specifically were designed and measured for preamplifiers. In other words, input cables. So we could change the sound of the input cables with these crystals. Once we got the mix, once we got the seed material right where we wanted it, then we would just duplicate it over and over and over and over. This particular one here is used as a stereo synthesizer. A mono signal goes in to the substrate, and the right channel comes out, and the left channel comes out. So it's all a one-wire system, basically, with a common ground. So this here this crystal here is being used for a big power amplifier, a 200-watt power amplifier for running the speakers.
So you would figure out ahead of time what you needed.
Yes.
And then go through the process to produce what you actually... So you pretty much had it dialed in then?
Yes, we did.
Yeah.
And the only reason that we got into this was because it was not copyable. You couldn't copy it.
Yeah.
Yeah, when you finished forming that crystal, what happens to the waste product?
Well, see, it dissolves all the way down, everything evaporates, and it leaves the crystal.
Oh, okay.
So there is no waste.
Yeah.
Because, see, it's growing. See how it's growing on there?
Yeah.
And if you really notice it, it's soft.
Mm-hmm.
See it? It's almost like it's little fibers that are meltable.
So it's not granular?
No.
Yeah.
So
How long does it take to grow?
it takes anywhere from 3 weeks to 2 months easily. Because depending on how much material you're putting in here,
Right.
you have time for the evaporation process. Because you're not going to touch it. You're going to leave it facing towards that position
Right.
until it's done.
Yeah.
And then what you're going to do is you're going to dry this out. You're going to take it outside, hang it up, and dry it out. It's not going to fall off there. See? And when it's all dry, you're going to scrape that powder off into a crucible. And then you're just going to grind it fine like this.
Right.
Or like this.
Yep.
Okay.
How do
So-
you grind it? What do you grind it with?
You grind it in a crucible.
Pestle and mortar?
Yeah, pestle and
Oh,
mortar.
okay.
You're gonna fire it on a ceramic block in an oven on a substrate crystal. Anyway, we were talking about this crystal right here. This is a power crystal, okay? So this crystal was used in a speaker line, and that box looked like this. with speaker terminals. And see, at one time there was a bypass switch up here, which you could take the crystal in and out depending, so you could AB.
What do you mean take it in and out?
Well, you could take the crystal out of the system and put it back in the system.
Not physically, but just by the switch.
Yeah, just by the switch. Call it
And where would the crystal be?
The crystal is sealed inside this block, with the wires coming out and the ground terminal, and then the inputs and the outputs. This happens to be for a preamplifier. See, it says ionic line amplifier. That's one of these crystals right here.
Well, and that would be that crystal right there.
Yes, these all measure the same.
Right.
So these are test sample crystals, of which we mounted to a board so we'd have
Go
a
into
reference.
the Bedini
Yeah.
ionic line amplifier.
Yeah. And basically that's what the box is. These are kind of beat up, but because they've been around forever, but the original box said the Force.
Oh yeah. And there was a bit of a legal problem.
Yes,
with
there
it.
was. George Lucas made us take the off when he patented or when he trademarked the name. See, we were already using it, but that didn't count.
Oh, so that was from Star Wars.
Yeah.
Okay.
This is a little bit before Star Wars because we were looking for something that was unique in the marketplace, and just by accident, out of growing all these different seed materials, this is where Tom Bearden talks about where was the mine. Well, the mine was right here.
Yeah.
This was the mine.
Huh.
Everybody says, well, where's the mine? Where'd you get this stuff? Well, I wasn't going to tell them that I grew it. So that I had to get some special kind of rock or something, because I'm not trying to make anything mystical here. I'm showing you straight up front, this is how it was done.
Well, in actuality, animals transmute materials all the time. Like Louis Kevron was nominated for a Nobel Prize for depriving chickens of calcium, and they produced eggs anyway.
Of course. You see, when you heat something and you grow a seed material like this, what happens when you heat it and you fire it at that temperature is it transmutes it.
Yeah.
Anything can come out of here, like it says here.
So you could never really tell what.
No, we had to have it assayed, and if you look very closely, I pointed here with a black arrow that this material here produced gold underneath.
Yeah, that is not pink gold. That is
regular That's
yellow
regular
gold.
Yellow gold. 1 electron off.
What do you mean 1 electron off?
Well, when they do the analysis, he said that it was gold, but they haven't seen a gold like that.
Huh.
Okay, when they brought back the assay, then when they actually broke this down and flame tested it, and they looked at it under a microscope and everything, they said they never seen a black ruby with silver particles in it. And you can see, if you look very closely, this has very little fine silver specks in it.
Yeah, you really need a microscope.
Yes.
Yeah.
Hold on. Let me see.
And then it's red in color. It just looks black. Yes. And a good way to see that is right here. See the gold color here? And then if you look at the side, you can see where it's transmuting the gold in veins here, as you said, Pat. It's little veins.
Bring it down a little bit.
It's little veins, and then this is ruby. This is actual red ruby. That just happens to be this material. See, and then what you do, you take this, after you take this off and you scrape it completely off, then you can get at this gold, you know, and then when you go to scrape it with something, you can tell that it's gold because it's so soft that it just scratches very easy. When you know that this material is not scratching.
Yeah.
So is any of that a slab of pure gold, or is just little bits of?
No, it's just a layer of it.
A layer of gold. Okay.
Yeah, it's just a layer of it that's combining with the material to form an electrical conductive. So the question was, where's the mine? Because it was rich in the gold, or it was rich in the silver, or it was rich in zinc, or it was rich in gold. Well, the mine was right here. There's nothing to it.
Yeah.
It works exactly like your stomach. It's not a big mystery. Why it was a secret for so many years is beyond me. And that basically all came from the paperwork that John Sajeka had hidden away for many years. And he taught us exactly how to do this.
How did he find out about it?
Well, I can't say because he would never answer that question.
Yeah.
Where he got it, or how he found it, or who it came from, or...
Why do you think he had it as a secret for so many years?
Well, because it's possible that if you seed the material just right, that you could produce gold. Or you could produce, you could produce silver, you could produce zinc, you could produce... And it would be a fraction of the cost. I mean, what does some distilled water cost and some hydrochloric acid and a steel rod?
Yeah.
You know, that's not how industry does this. But this goes to show you that they might have even known this during the 1900s or the 20s, 30s. But he wasn't going to tell.
Well, Tom said that 40% of the gold that the Russians sell is made in the lab.
Well, yeah. Well, this would be making it in the lab.
Yeah.
The hard way. Actually, the easy way.
Yeah.
But you would say, you might be thinking to yourself, this is very hard to do because you got to wait the time, but no wine before it's time.
Yeah. Do you know anything about monatomic gold or white gold? Or
No.
No.
Never messed with it.
Yeah.
Heard about it, but never messed. You mean powdered gold?
Yeah.
White powdered gold.
Yeah.
Well, I do know that when you're making colloidal silver, that even though you have silver electrodes in there, the colloidal silver is gold in color.
Yeah.
And when you're making colloidal gold, it's white.
Right.
So why would you want to make colloidal gold unless you were trying to do something with DNA?
I don't know.
What do you mean?
Maybe you want to extend your DNA or something.
Yeah.
You know, it's
Well,
just something that I heard a while back. And
gold and silver are right next to each other.
Yes, they are.
On the periodic table.
Mm-hmm.
Yeah.
So it's not far to transmute one from the other. John Sajeka was a big fan of Walter Russell. So if you look at Walter Russell's chart,
Right.
it sort of looks like this. And then all the elements are in here.
Right. And this is very different from the periodic table that we're taught.
Right. So, you see, in this cycle here, right, you might have Cu here, which is going to be copper,
Right.
right? And you might have gold Ag here.
Right.
So what's the difference between the two? Is a harmonic shift.
Right.
You see? It's a frequency shift. Because silver may be right here. Right here. Zinc may be right here.
Right.
And lead may be right here. But if you look at Walter Russell's chart and you look at what it would take to move copper to gold, is a frequency shift back down to this level.
Yeah.
So if you can do something to this copper, right here, this substrate, if you can do something to it by seeding a material on top of it,
Right.
right? And then you fire that in an oven, what happens is it's going to transmute at that level, whatever is in here, it's going to transmute it to this material.
Right.
And so when you take this layer out and send that for assay, that's what was in the material.
Okay.
So see,
Right,
maybe
right.
Walter Russell isn't so far off putting the chart together the way he did.
Yeah.
After all, he did say that there's the positive spin and the negative spin.
Of what?
He called one a male and one a female, if you read his book.
Oh, right.
You know, he called one plus and one minus.
You mean the elements? He called those elements. Plus.
Yeah, well, he talked about life, about these two frequency shifts. You know, I think he had a drawing something like this.
Yeah.
So I had to check it out. And I had to try it for myself, and I was thoroughly convinced after being booted out of the hi-fi industry with this stuff. And we did do it. We were able to successfully prove that it was possible to build these room temperature semiconductors and use little bitty wires to transfer power. Okay, without any signal loss whatsoever and no heating in the wire. And we were using 200 watt amplifiers, 300 watt amplifiers. And we also found out that it was possible to make a big substrate, say bigger than this disc here, about this size, that we could put the material in this stuff, which is like a plastic, and then we could take that stuff and put it between two copper plates like this, and we had a perfect capacitor, 3.9 microfarads.
Well, going back to this one here, what is this now?
That's this material.
That's, okay.
See, that's this material. This has been sanded off so you can see.
Okay.
You
So
see
you
it
just
dry.
made it bigger physically.
We made it bigger so you could see it,
Right.
so we could see it.
Right.
And then we would look at that material, and this material becomes something like a dielectric. It is a dielectric then. And then if you put it between these two plates, you get a capacitor. So we were able to build in a capacitance with the material into the crystal by putting these components, which were never seen or heard of, in the box, because they were bandsawed open and they didn't know what they were looking at, because they didn't know any such technology.
Yeah. These are.
Has that one been bandsawed open?
No, this one was broken open to check these jacks. And notice it's tuned. It's tuned between the grounds with this little coil here. Can you see that? Right here.
Yeah.
See, and then this ground connection was to the case, like that. And that's the ground of the substrate underneath here. But in this block, is this chip. And a capacitor made from this material. So, therefore, since you don't know the technology, you can't comprehend it.
Right.
Because you can cut it day and night and try to figure out what it is. But when it's not electrical, the same way you know electrical, you know, you're scratching your head a long time. In fact, to this day, they don't know.
Yeah.
And probably never will, and never know how to do it exactly.
Even though you're showing the right
Even though I'm showing you.
Yeah.
And just back
You have to know what you're looking for.
Yeah. Yeah.
And that's one part that I can't give you.
Right.
You know, but I can talk about it.
Right. Right.
So, and I can tell you that it's based because Sajeka was very persistent on what Walter Russell said on this chart of elements. Because many times he would say, John, and this is exactly how I'd say it, John, where's the copper? Well, it's right here. Okay, how many down is it? 3, 2. He'd say, now go down there and find gold. And so I'd go down to the chart and I'd find gold, right? And he'd say, what do you need to do to get gold? Well, you have to transmute the copper. So it isn't lead, like they tell you. It's copper. And when you do the same thing with silver. He would repeat that over and over and over and over. John, here's silver. So what do you need to do to get zinc? And you'd go down here and you'd look, and it's just a frequency shift between all these materials. And it's been in Walter Russell's books forever.
Yeah.
Forever. But see, what I want to point out here is this doesn't make anybody a magician. What this says right here is you, the person that's trying to do this, have a lack of understanding. And so therefore you can't comprehend it. You think it's BS. But this has been in front of the public forever.
Yeah,
You see, so things that we don't understand, we burn it at the stake. It's gone forever. You don't ever want to hear about it again in your life. You got this big mental block about, oh, it can't be done. Oh, that doesn't work that way. My meter doesn't measure it. Well, I'll tell you what. Your whole body's a big meter.
John, back to that Walter Russell thing with the two spirals, one connected
Mm-hmm.
one. That doesn't have anything to do with the spin of the Earth, does it?
No.
Okay.
It had to do with what Walter Russell was shown when he was in that coma. Because remember, he was in that coma for a long time. And when he came back, he knew exactly what vibrational rate all these elements and everything were. Because he was shown. Okay? And we may be talking about that we live just here. But all these other things are at different levels. And what I get from all this is what Walter Russell was talking about is all you have to do is change your vibrational rate and you move up to a whole new realm.
Which is what some of the religions believe.
Right, that's what some of the religions believe. But suppose that you change the vibrational rate of things that are physically on this earth. Well, then it's possible. Maybe John Sajeka was right. Copper is gold. And silver is zinc. And platinum is antimony. Who knows? You know, it would take a lifetime for a person to do all this. I did nothing mystical except study the science and understand the science. And now I'm telling you the science. That's how you do it. And it's up to you to do it. I can't do it for you.